Section 2. Elements and their properties. Chem Talk. Physical and chemical properties. Classifying elements using properties. You began this section by trying to define the meaning of an element. The ancient Greek philosopher Aristotle defined an element as a body into which other bodies may be analyzed, and not itself divisible into bodies different in form. The first modern definition of element, which is not much different, is from Robert Boyle: bodies, which not being made of any other bodies, or of one another, are the ingredients of which all those mixed bodies are compounded. Scientists now state that an element is any material that cannot be broken down by chemical means into simpler materials. Before the mid-19th century, scientists were busy discovering elements and observing and recording their properties. Then they tried to organize the elements they had discovered in a useful way. At first, they listed the elements alphabetically. However, every time a new element was discovered, the whole list had to be changed. They tried other methods. Could elements be organized by properties like state, solid, liquid, or gas, color, or taste? None of these methods appeared practical or safe. However, chemists worldwide were sure that elements existed in families that had similar physical and chemical properties. To the Russian scientist Dmitry Mendeleev, 1843 to 1907, the development of a tool to organize the elements began the same way that so much of science inquiry begins. He began with a simple question. The question Mendeleev wanted answered was, what is the relationship of the elements to one another and to the chemical families to which they belong? At that time, there were 63 known elements. To help him with his organization, he developed a card system, much the same as you did in this investigation. He wrote the properties of each known element on a different card. Then he spent many hours arranging and rearranging the cards. He was looking for patterns or trends in the data in front of him. Mendeleev, however, had more information on his cards than you presently have. In the following sections, you will look at additional properties of elements that will help you organize your game. Physical and chemical properties. In this investigation, you observed several properties of the elements you were provided. You probably initially observed the color of the element and whether the element was a liquid or a solid. You then investigated whether or not the element conducted electricity. You could have also observed the luster, measured the density, or the strength, or determined the malleability of each element. In each case, you would not have changed the element itself. In this investigate, the element in the jar still looked the same after you removed the electrical conductivity apparatus as it did when you initially inserted it. It was unchanged. If measuring a property of a substance does not change the chemical identity of the substance, you are measuring a physical property. On the other hand, when you observed whether the element reacted with hydrochloric acid, some elements clearly changed into another substance. A chemical property is a property that is displayed when matter undergoes a change in composition and a new substance is formed. The original substance becomes a different substance with new chemical and physical properties. A chemical property of zinc, for example, is that it undergoes a chemical reaction with hydrochloric acid. The lack of a reaction between two substances can also be a chemical property. For example, one of sulfur's chemical properties is that it does not react with hydrochloric acid. When elements combine with oxygen, they form oxides. In the investigation, you saw that the oxides of metals are basic, meaning they have a pH higher than 7, and oxides of nonmetals are acidic, meaning they have a pH lower than 7, when tested with a universal indicator. You know that cars and coal-generating power plants emit sulfur dioxide and carbon dioxide into the atmosphere. When these nonmetal oxides combine with water, they produce acid rain. Your tests on the nonmetal oxides should have confirmed this observation.